Here we have a similar example, example number 6, solve the equation by completing the square. We complete the square by using the x squared term and the x term, so I'll move the constant to the other side of the equation, and I can do that if I add 12 to both sides. And that's going to leave me with x squared minus 6x. And on the right hand side, 0 plus 12 is 12. Now I have to complete the square, so I need to add the value that will give me the perfect square trinomial here on the left hand side. And to do that, I'll grab the b term, divide it by 2, and then square it. The b term is the coefficient of x, so here that's the negative 6. So I'll add by a value of negative 6 over 2, quantity squared, and whatever I do to one side of the equation, I'll have to do to the other. So here I am also adding by negative 6 over 2, quantity squared. Now on the left hand side, I'll have the perfect square trinomial, x squared minus 6x plus, and simplifying what's inside of the parentheses, negative 6 over 2 is negative 3, quantity squared, and on the right hand side I'll have 12 plus negative 3 quantity squared. I can exchange the perfect square trinomial for its binomial squared. And to find what goes inside of the parentheses, all I have to do is grab the x term and then grab the negative 3. So here I have x minus 3. And on the right, I'll have 12 plus negative 3 to the second power. That's going to give me a positive 9. With a little bit of simplification, I have the statement x minus 3 quantity squared equal to 21. Next, I'll get rid of the square by taking the square root of both sides. And doing this, the square and the square root are going to cancel out on the left, leaving me with x minus 3. And on the right hand side, 21 is not a perfect square, and I'm not going to be able to simplify this any further, so I'll leave it as plus or minus radical 21. To isolate x, I can now add 3 to both sides of the equation, and I'll get x equal to 3 plus or minus radical 21. So my two solutions are x equal to 3 plus radical 21 and x equal to 3 minus radical 21. Okay, let's try problem number 7. Solve the equation by completing the square. Now here I immediately notice that the coefficient of x squared is not 1, it's 2. So I'll begin by dividing the entire equation by 2. So here we can divide each of these terms by 2. And I'll be left with x squared plus 10x minus 2 equal to 0. Now that I have 1 as my leading coefficient, I can begin to complete the square. So I'll move the constant to the other side of the equation by adding by 2. And I'll be left with x squared plus 10x on the left hand side. And then on the right hand side, I'll have 2. And to complete the square, I'm going to grab half of the b term, which is going to be 10, and divide it by 2, and then square it. Whatever I do to one side of the equation, I have to do it to the other. So here on the right hand side, I'll also add by 10 over 2 quantity squared. On the left, I'll have x squared plus 10x, and simplifying what's inside of the parentheses, I'll have 5 raised to the second power. On the right hand side, I'll have 2 plus 5 raised to the second power. On the left, I can exchange the perfect square trinomial for x plus 5 quantity squared. And on the right hand side, I'll have 2 plus 25. With simplification, I'll have x plus 5 squared equal to 27. And to get rid of the square, I can now take the square root of both sides of the equation. On the left, the square and the square root are going to cancel out, leaving me with x plus 5. And on the right hand side, I'll have plus or minus radical 27. To isolate x, I can now subtract by 5, and I'll be left with x equal to negative 5 plus or minus root 27. While the 27 is not a perfect square, I'll be able to simplify it if I get its prime factorization. So here 27 is the same thing as 9 times 3, 3 is prime, and then the 9 is the same thing as 3 times 3, and now I have all of the primes. Because we're taking the square root, I'm going to get pairs. So here I have one pair of the same quantity. So for each pair, one of that quantity is going to be outside of the radical. What remains inside is the stuff that you weren't able to pair. So here we're left with 1, 3. And we have the simplification, x equal to negative 5 plus or minus 3 radical 3. Moving on to example number 8, solve the equation by completing the square. We will use a similar approach to the one in number 7. Here I realize that the leading coefficient is not 1, so I'll divide the entire equation by negative 3. So here I'm going to divide everything by negative 3 to remain equal, and I'll be left with x squared. And now here 36 divided by negative 3, that's going to give me a negative 12x. And then negative 9 divided by negative 3 should give me a positive 3. Now that my leading coefficient is 1, I can begin to complete the square, but before I do that, I'll move the constant to the other side of the equation, so I'll subtract 3. And now I have x squared minus 12x equal to negative 3. I'll begin to set this up for completing the square. And to complete the square, I grab the coefficient of x, here that's negative 12, divided by 2, and square it. Whatever I do to one side of the equation, I have to do it to the other, so here I'm also adding by a negative 12 over 2 quantity squared. On the left hand side, I'm now left with the perfect square trinomial x squared minus 12x, and simplifying what's inside of the parentheses, negative 12 over 2 leaves me with a negative 6, and that's quantity squared. On the right, I'll have negative 3 plus negative 6 raised to the second power. On the left, I can exchange the perfect square trinomial for its binomial squared, and I can do that by grabbing x and the negative 6. So I have x minus 6, and on the right hand side we have negative 3 plus negative 6 squared. That's going to give me a 36. Simplifying this, I have the statement x minus 6 quantity squared equal to positive 33. Next, I'll get rid of the square by square rooting both sides of the equation. This is going to cancel out the square and the square root on the left hand side, and I'll have x minus 6 equal to, and 33 is not a perfect square, and I cannot simplify this either, so I'll leave it as plus or minus root 33. And now to isolate x, I will add 6 to both sides of the equation, and I get my result as x equal to 6 plus or minus root 33. Let's move on to example number 9, rewrite in vertex form. Now, when we wish to convert a quadratic equation that's initially in standard form to vertex form, we emphasize the x squared term and the x term. Then we will proceed by completing the square. So here I'll have y equal to x squared plus 14x, and then I have to add the value that's going to make the perfect square trinomial. I still have that plus 21 right here outside of the parentheses. Now, because we have an equation, whatever I add, I'm going to have to subtract. So here I'm going to have to subtract by that same value. To find that value, I'll get the b term divided by 2, and then I'll square it. The b term is the coefficient of x, and here that's going to be the 14, so I'll graph 14 divided by 2, and then I'll square that. Simplifying what's inside of the parentheses, 14 over 2 is going to leave me with a 7, and then 7 squared, that's going to be 49. To complete the square, I need to add a value of 49, and in this case, I'll also have to subtract by the 49. Now that I have a perfect square trinomial, I can exchange that part for its binomial squared. And to do that, I can grab x and then add half of the coefficient of x. So half of 14 is 7, or we already did that part here. And 21 minus 49, we can simplify that, and that'll give us a negative 28. And here we have the vertex form. Now let's look at example number 10. Here we need to rewrite in vertex form. Similar to example number 9, we're going to focus on the x squared term, and we're going to focus on the x term. Here I notice that the leading coefficient is not 1, so I'll have to factor out the 3 first. That's going to leave me with y equal to 3. And then 3x squared divided by 3 is going to give me x squared. And negative 12x divided by 3 is going to leave me with a negative 4x. I'm going to add by the value that will give me the perfect square trinomial. I have the minus 4 outside of the parentheses, and I'll need to compensate by including the value that I need to subtract in order to keep the equality. But here, since we have a factor other than 1, we're going to need to get the opposite. So the opposite of positive 3 is going to be negative 3. And we will multiply it by whatever we used to complete the square. And to complete the square, I'll grab the b term divided by 2 and square that. Here the b term is negative 4 since that's the coefficient of x. So I'll grab negative 4 divided by 2 and then I'll square that. Simplifying the negative 4 over 2, that's negative 2. And negative 2 squared gives me a positive 4. So I have to add 4 and then I'll put a 4 right there as well. I can begin to simplify this by exchanging the perfect square trinomial into its binomial squared. And I do that by grabbing x and adding half of the coefficient of x, which is negative 2. And then here I have negative 4, and negative 3 times 4 is negative 12. Combining the negative 4 and the negative 12, we get a final result of 3 multiplied by x minus 2 quantity squared minus 16, and that would be the vertex form. Let's check out example 11. A penguin dives into the ocean to catch fish. The height of the penguin in feet, y, and the time it takes in seconds, x, can be modeled by the equation y equals x squared minus 8x plus 12. When does the penguin enter the water? So here we have a scenario where a penguin is diving inside of the water. If we look at this little diagram, we can see that we are trying to find the x-intercept, okay, the first x-intercept. So to do that, we need to solve this equation for x. And for us to be able to find the values of x, we got to let y equal 0. So here I have 0 equal to x squared minus 8x plus 12. And now I have to solve this by either factoring or by completing the square. I find it more efficient to factor since I can find the two numbers that multiply to 12 but add to negative 8. So to do that, I'm going to get organized here with my little x diagram. And I need to find the two numbers that multiply to 12 but add to negative 8. And after some trial and error, we're going to see that the two numbers are negative 6 and negative 2. Negative 6 times negative 2 is positive 12, but if we add them, we'll get the negative 8. That means that we can let 0 equal x minus 6 multiplied by x minus 2. And because we have the product of two things, and that product is equal to 0, I can set each factor equal to 0. So x minus 6 equal to 0, and x minus 2 equal to 0. Solving the first equation, we're going to get that x is equal to 6. And solving the second equation, we're going to get that x is equal to 2. So we have 2 and 6 here because we are trying to find the first x-intercept. We're going to say that the penguin dives at 2 seconds. The penguin enters the water at 2 seconds. Let's look at another application problem, example number 12. Here, your favorite basketball team is playing today. One player throws the ball straight up into the air in hopes of making it through the hoop. The height of the ball in feet y and the time it takes in seconds x can be modeled by the equation y equal to negative 2x squared plus 12x minus 8. How high does the ball get? So here we have a scenario where a basketball player throws the ball and we're trying to see how high the ball gets. So here we're trying to get the y value of the vertex. And to get the vertex, we will need to convert this equation that's initially in standard form into vertex form. To convert this, I'll emphasize the x squared term and the x term. I notice that the leading coefficient is not 1, so I'll need to factor out that negative 2. So here I'll have y equal to negative 2, and in parentheses I'll get negative 2x squared divided by negative 2, which is x squared. And I'll get 12x divided by negative 2, which is negative 6x. And I'm going to erase this picture to make more room. I'm going to complete the square inside of the parentheses. And I have negative 8 outside of the parentheses. Because I have a factor other than 1, I need to get the opposite here. And the opposite of negative 2 is positive 2. And I will multiply it by whatever I use to complete the square. To complete the square, I'll need to get the b value divided by 2 and then square it. Here the b value is negative 6, that's the coefficient of x. So I'll get negative 6 divided by 2 and then I will square that. Negative 6 divided by 2 is negative 3. And negative 3 squared is positive 9. So here I'm going to add 9. And I'm going to put the 9 right here at the end as well. I can begin to simplify things now. So I'll get y equal to negative 2. I can exchange the perfect square trinomial for a binomial squared by grabbing x and adding half of the coefficient of x. So half of negative 6, that's the negative 3. And then I have negative 8 plus 2 times 9 is 18. Doing the final simplification, I get a total of y equal to negative 2, x minus 3, quantity squared, and negative 8 plus 18 is 10. The vertex is going to be positive 3 and 10. Here I'm interested in getting the height of the ball, which is the y value of the vertex. So here our result is going to be 10 feet.